Morning, D3M Warriors. I just want to follow up on 3 points from the other night, 2 points of follow-up, and 1 point of new instruction. And these will help you headed into homework number 4. At the risk of saying always convert to the z-score. This is point number 1 in my video today. And this will help you be bulletproof working these problems. So what am I talking about? Well, the other night I talked about if you know it's on the number, you didn't have to convert to the z-score. But after thinking about it and talking with some of the warriors in the class, I think it's the best practice to go ahead and do that conversion. So let's say we have a normal distribution with a mean of 100, standard deviation of 10. And we want to find out how many people, what's the probability that someone will fall at the score of 90 or below. So we're going to go ahead and get that lay of the land. Mean's going to be there at 100. One standard deviation to the left is going to be 110. And one standard deviation, to the right is 110. And one standard deviation to the left is 90. Now, there's a couple ways we could solve this. Let's talk about the z-score table way, which is our bulletproof way. So let me get into a different color. We're going to work over here on the right side of the screen. So we're going to take our handy-dandy z-score formula, which is z of 90. We're going to get in that muscle memory habit, 90. Just shoot that over there, 90 minus that mean, divided by that standard deviation. That's going to give us a z-score of -1. From here, we're going to go to our handy-dandy cumulative probability table. And we know how to find that. We're going to go down that left-hand column to find -1. And we don't have to go any more over to the right because it's -1.000, etc. And that value of probability is going to be 0.16. Okay, and again, that tells us who falls at this here or below. So we are talking about this area here. Right there. And again, because we graphed this ahead of time, we know this should be a small number compared to a big number, and sure enough it is. So we're good to go. That's the answer of how many people will fall at 90 or below. Now, there's another way we can solve this problem, and again, my point is to get into this habit of converting to the z-score. Converting to the z-score. A different way, not necessarily better, it depends on what works for you, is to look at this and say, well, I know that from the left tail to the right, this half of the curve, this entire thing is 0.5. And I also know that this here is 0.34. So if I take 0.5 and I minus 0.34, that will give me 0.16 as well. So I could do it either way. My point here was I just wanted to encourage always converting to z-scores and then go into that cumulative probability table. I also encourage always drawing. So you just visually get, because when you draw, you can see, okay, this is what I'm talking about. This is what I am not. We're also not talking about this area here. So when I do get this number, it needs to be a small one or I have the wrong number. That kind of thing. But and then converting to the z-score. Z-score is not probability, but I can read the table and get this value. Or I can use my knowledge of the normal distribution to say, if this half is 0.5, and I'm not talking about this area here, which I know is 0.34, then I am talking about this area here, which is 0.16. My next point is on rounding z-scores prior to heading into the z-score table, the cumulative normal distribution table. So what do I mean? Well, let's say we have a z-score of negative 3.666. Kind of a scary number. So we go down here. We don't want to head into this table with that. We want to round that to negative 3.67. Because if we head into the z-score table with this, negative 3.666, we're going to go down here to negative 3.6. We're going to go over here to 0.06. That's going to cover us for negative 3.66, but that extra decimal place is not covered. So what we're going to do is we're just going to round up, and we're going to take that as our probability that corresponds to that z-score. So we're going to round accordingly. I'm going to tell you if you get something like negative 0.3665 or higher, go ahead and round to that next higher number, which would be negative 3.67. If you get something like negative 664, then you're going to round down to just negative 3.66. So very simple, but you want to do this before you head in here. You want to, as you're going through, you figure out your z-score, you want to round accordingly and head in here so you just don't get confused and start getting lost down here. Pretty simple, but also very important. Round to two places before you head in, and then we'll go from there. Okay, and my last point today is how we, if we're given a probability, how we find the value of that probability. And this is a little bit counterintuitive. So value, or in this case, we're going to say x. So up to this point, we've been given a value. We've got to do the reverse. And we've determined the probability. So we're going to focus on how to do this. And the bottom line is that it's essentially, if you know how to do this, you essentially reverse the steps. But I'm going to go through the steps. So let's suppose that we have a bottle. We're manufacturing bottles of a protein drink, of course. And we want to know the value of volume that corresponds to that 98% volume mark. Okay, so we want to know when the bottle is 98% fill, what is that in terms of volume? Is it 14 ounces? Is it 13.5? Is it something else? And of course, going into this, we've got to know the mean and the standard deviation. So essentially what we're doing is we know the mean, the standard deviation, we have a probability, which doesn't, at face value, this doesn't fit into any formulas that we have, but we're going to find a z-score, and that fits. So that takes us to the first point. We want to go to our cumulative probability table, and that's that inside of the table, and we want to find the corresponding z-score. And we know that we do that by going to the inside of the table. These values in here, we want to look up here and over here to see where that probability, how that translates into the z-score. So we're working our way from the inside out. Whereas on this type of problem, we work our way from the outside in. So we want to find that z-score. And then we are going to use the formula z times the standard deviation, which we should have, plus the mean, which we should have, to find the value, x, that volume of the protein drink when it's 98% full. And that's how we do these kind of problems. Now, when you think about it, if you're working for those mad skills, which we all are, this formula here is really the formula we've been using to find the z-score in the first place, which is z equals x minus the mean divided by the standard deviation. Well, how do I know that? Because if I do some algebra here, I can do this, and I can do this. And this is that. So, put another way, if I know how to do this bottom problem, I have x and I want to find the probability, then I can fight my way out of the reverse. I find the probability, I turn that into a z-score, and then I put this in to the same formula I've been using before, but now I want to solve for x and not find a z-score. And that x is the value that I'm looking for, the volume of the protein drink. So give that a try. Again, to recap for this video, always convert to the z-score so we can be bulletproof headed into these problems, regardless if it lands on the actual line itself, meaning an even break within the normal distribution. Point number 2, round to 2 decimal places your z-score before you head into that cumulative probability table. And then number 3, here's how you do problems where you have a value and you want, or excuse me, a probability, and you want to turn that into a value. So give that a try, and we'll see you soon.